Hello, today I want to talk about inheritance in C++. To get us started, let's consider this class called person. It has three members and three methods. It also has a constructor. On your right, you can see the main file, the main.cpp, and here we construct an instance of class person using the constructor provided here, and we also print the information. So let's see how it works. I build my program and I'm going to execute it, and it's working as expected. You see that I've already set up a Makefile for my program. Now I want to construct a student file that will inherit from a student class that will inherit from this person class. So let's do that. Let's create a student.h file. I always put my class within the if not def block to avoid multiple inclusions during compile time. So I'll just simply do this, and here we go. Now I want to inherit my student class from the person class, so let's include person.h file. Then I'm going to start my student class, and I want to inherit from the person class, so that takes care of that. And here I have an empty student class that is inheriting from the person class. So in this case, I would say that student is a subclass of the person class, or student is a child class of the person class. Let's create a member in the student class. Let's call it int year, which stored the year the student is in. I will also provide a constructor for the student object. And I want to be able to construct my students by providing their name, their age, and their SIN number. When a student is constructed, the year is automatically set to 1. So my constructor will take a name, the age, and the SIN number of the student, and it will set the year to be 1. Now I have a couple of options. One option is that I can, since student is inheriting from the person class, so I have access to all the members of the person class. So in theory, I can write something that looks like this. So I can set the value of the SIN number to be equal to SIN num, name to be equal to the name that is passed as the argument to this constructor, and also the age. Now this is not the correct way of doing it, and you can immediately see a problem. The SIN num is declared private in person class, so it is not actually accessible within this method. This method is belongs to the student class, not the person class. So this thing is just going to give us a compile error just from the get-go. But I can do better than that. You notice that what I'm doing here is very similar to this constructor of the person class. So why don't I just call the constructor of the person class instead of duplicating the code? Code duplication is never desirable. So in the future, if you have a bug in the code, you might have to fix that bug multiple times if you were to duplicate that code. Okay, so how do I call the constructor of the person class explicitly? I can use again the same way that we use initializer lists. I'm going to call the constructor of the person class, and I'm going to pass the arguments to it. So now my constructor for student is complete. I can go ahead and try to create a student in my main.cpp and see how it goes. So let's go to our main.cpp file. I'm going to create a student here. Student, let's call it Jane Doe. The age of the student is say 17. The SIN number is 222 and 444. Now, currently the program is not going to work because you can kind of see that I have to include the student file here. So I'm going to include it here. Include student.h. And I'm also going to print the information of the student. And let's see what happens. So let's print it. I'm not done yet. I have to update my Makefile to include student.h. So let's go to the Makefile that I have for this project. And here in the headers, I'm going to include my student header. Now let's try to build it. I'm going to say make. Everything works. Let's run it, execute it. So you can see it is kind of working. But one thing you notice immediately that my student is only printing the name, the age, and the SIN number. It is not printing the year. So what is going on here? What's happening here is that if you look at my student class, so I'm going to go to my, so let's go to my student.h file. If you notice here, student class actually do not have any method called print info, but I'm calling it in my main file. So student essentially is inheriting the print info method from the parent class. Now, one of the things that we can do in inheritance is we can override or redefine a method that is provided in the parent class. For example, if I want to redefine or override the print info method in the parent class, I can simply define it in the student class using the same function name, the same number of arguments, same return type, and here I can do whatever I want. So for example, in this case, I want to print the year of the student. So I'm going to print the year. The only problem here is that this method now will only going to print the year of the student and not the name, the age, and the SIN number. And we can double check it. So let's make our program again. Let's execute it. And you can kind of see that this is not exactly what I wanted. What I wanted was not, in this particular case, I don't want to simply change the functionality entirely. I want to add to it. So print info function of the parent class has some nice functionality that I want to use, and I want to add something to it. It is easy to do. I can actually explicitly call the parent info method in the parent class like this. So I'm explicitly calling the print info method in the parent class by providing its exact name. So I'm using the qualifier here. Okay, let's see how it works. I'm going to make my program again, and I'm going to run it. And now it seems it is working as expected. Okay, so now we have seen the basic idea behind inheritance. The idea being that the child class inherits all the members and methods of the parent class, with the caveat that any members or methods that are declared private in the parent class are not directly accessible in methods of the child class. We've also seen a very powerful feature of inheritance where it is possible to override or redefine a method in the child class to change or add to the functionality of the method provided in the parent class. In our example, we have overridden the print info method that was originally defined in the parent class. Now let's talk about virtual functions or virtual methods and how they play a role in inheritance. So let's go back to our main file, main.cpp. So one thing about inheritance is that every student is a person, but every person is not necessarily a student. And what I mean by that is that a statement that looks something like this is valid. So notice this statement. We have a pointer of type person, and I'm storing to this pointer the address of an instance that is of type student. This is only possible because student is a subclass of person. If student was not a subclass of person, then this statement would not, then you will get a compile error from a statement such as this. Now, it is also important to keep in mind that the opposite is not true, meaning, let's just copy that I cannot simply assign address of an instance of person to a pointer of type student. So this statement is not valid because every person is not necessarily a student, but every student is a person. Not allowed. Whereas this statement is allowed. So if this statement is allowed, then once I have P1, I can also try to print the information of this person. So I'm going to now use pointer notation P1 and pointer parent info, and let's not forget to delete P1. So let's see what we get. I'm going to make my program again. It works, and now I'm going to say run it, and you immediately notice something interesting. And what is happening is that the year is not being printed. And why is that? The reason is that, remember, while P1, a pointer of type person, is pointing to an instance of type student, when I call or invoke the method printInfo, it is invoking the printInfo method described in the person class. It is not invoking the printInfo method described in the student class. So how can we fix that? This behavior is different from those of you who have experience in Java. This kind of, Java doesn't have pointers, but in any case, this kind of work you will call the printInfo method defined in the student class. How can we fix that? And the virtual keyword can help us. So I can define a method or a function to be virtual. Virtual method in the parent class. And in this case, what I've done is I have now defined my printInfo method, declared it to be virtual using the virtual keyword right here. And let's see how system behaves differently now. I'm going to make it again, and I'm going to run it. And now you notice what's happening is the year is being printed. So essentially, at this point, when this part of code is executed, the printInfo method that is defined in the student class is executed. And this kind of behavior is made possible because I've declared this thing virtual. This is also called dynamic binding. So at runtime, the system, when it sees a pointer of type person, it inquires the pointer and say whether is it truly the type person or is it one of its subclasses. In this case, it turns out that this P1 actually points to not a person but actually a student being the subclass of person. And if it finds subclass, it tries to execute the method provided in the subclass. Of course, if printInfo method was not declared in student, then it will default to the printInfo method that is provided in the person class. So this is one way through which you can use inheritance to define interfaces, meaning that you can have a program that always works assuming some kind of a parent object. So you can have a program that can maintain a list of persons, but within that list you can have things of type students, type employees, type teachers, each of which will be a subclass of person, but your system will treat them as if each of them is a person. And this can be done through this mechanism of virtual functions. There's also one other thing in inheritance that is quite important, and that is, remember, in C++ we have to declare our we have to clean up the memory ourselves, right? So let's go back to our student class and notice that we haven't defined any destructors, both for neither for person nor for students. So why don't we define a destructor for a person? In this case, the destructor is not doing much because we haven't created dynamic memory, so we have an empty destructor, so to speak. And similarly, we have a destructor for our student object. So here we have a destructor for the student, and it is empty too. And destructors, again, you have the same issue where if you go back to your main class, main file, you will notice that the pointer P1, I'm deleting P1 here. So if I don't declare my destructor virtual, then this thing will not call the destructor of the student. It will only call the destructor of the person, and that can lead to memory leaks. If, for example, your student class allocates dynamic memory and then releases it or frees it in the destructor. So the best practice would be to always declare your destructors as virtual. If you declare your destructor to be virtual, then the student destructor will also be called, and in anticipation that somebody in the future will inherits from the student class, I'm going to declare my destructor in the student class to be virtual as well.